yourself and start now. Go ahead with your talk.
Okay, so good morning, everyone. I'm Felipe Bidu, and I will be talking to you today about humans and code and what's in some of the relationship between those two entities. Um, Later, I'll have this talk available on my GitHub that you can see in the bottom of the screen, and you can see all my presentation notes by pressing the S key. So, as I said, I'm Felipe Bidu. I'm from the Institute of Computing at the University of Campinas in Brazil, and I'm a senior software engineer at Ingresse. That's a ticketing company here in Brazil. If you ever come to Brazil, buy tickets from us. We're nice, a very nice company. So, I started by talking about some general features of software development itself. There is a debate whether software engineering is an engineering in itself or not, and where it fits into the spectrum of technical and scientific areas. In any case, our area has a capacity that is rare and very, very important. This is introspection. The ability that we have to build software that solves problems that we have in the software construction process. It is an aspect of our area that may go unnoticed by us, but when we start to pay attention to it, it is everywhere. So, for example, a software development sprint of ours may start with us or a colleague using softwares like Jira or Trello to describe and manage the tasks that we need to run within the software we are authoring. Then we use another software like Git to organize our code, collaborate with our peers, and so on. And finally, it's deploy time. There we have a whole new pile, affectionately called a stack of software to deal with. Containers, CI servers, CD servers, the production servers themselves, monitoring panels, etc., and etc. At the end of a feature, a single developer will have contact with dozens of different softwares, only so that they can develop one single new software. From our IDEs and editors through our linters, testers, automation, etc., our code is processed by a gigantic amount of other software along the development line. And it begs the question, is this all bad? I think this introspection, this capacity that software development has to look at itself and make use of its own area to solve their problem, it's an incredible thing actually. However, are easy in creating new software to solve problems of the software creation process itself can make us enter a vicious cycle, thinking more about software on top of software on top of software and so on, than about other aspects of our creative process, like our colleagues, our workplace, the market in which we operate, the increasingly complicated ethical relationships between generation and usage of customers' data, among other things. In fact, with the popularization of computers, cell phones, and IoT devices, the relationship between the digital world and people's physical lives becomes increasingly complex. We can no longer talk about information security, for example, without thinking about the very real impact that those decisions will have on the personal lives of our users. We can also no longer discuss the systematization and scaling of certain markets through a software solution without considering the social and commercial relationships which were already involved in that market and that will certainly be deepened and intensified by our codes. In our defense, our area is still in its infancy. The first commercial software was manufactured in the early 1960s. Software development is practically a baby when compared to areas such as building architecture or something like that. On the other hand, those discussions are becoming increasingly important. I've been working with software development for many years now. The first time I saw a serious discussion about the ethics of our area was in 2015 when they discovered Volkswagen Dieselgate scandal, a software that distorted pollution emission tests. The slide's a little broken, but there's actually a link over there later. You can read more about this issue if you'd like. So there are a lot of important things to discuss between these human software relationships, but let's start with baby steps. Today, I want to discuss with you particularly about the part of software development that is probably closer to the developer itself, the code. Let's start by considering the question: who or what is the main reader of our code? It may be tempting to answer that the main target audience for a code is a computer. After all, we write code to make the machine work for us. On the other hand, we know that some aspects of a code, such as choosing a concise name for functions and variables, and a very well done formatting, documentation, and so on, these are not relevant to the computer, but we know that those things are important. What you're seeing right now is the general diagram of a compiler with all the steps that a code goes through, starting from up there in the left corner until you get something that a computer will actually understand in the bottom right corner. Our code, in its broadest aspect, only really matters for this process until about the third box. After the fifth stage, the translate stage, not even the programming language that we use it matters anymore. And we are not even halfway to the computer yet. So I ask again, is our code primarily meant to be read by a computer? Today I came here to defend that it doesn't matter how much software we use to write software. It doesn't matter that a processor, a CPU is at the end of the execution chain. Codes are written to be read mostly by human beings. The central issue for me is that software, in the sense of a digital product or in the sense commonly used within software engineering methods, such software is not a small piece of code that you write in one day by one person and you throw away in the next day. Software, in the sense that we use, they are complex collaborative works in which ideas are materialized through code. In software like this, the code acts as a means of communicating abstract concepts thought by a colleague, shared to others, and developed by many. Before a code falls into a deployment pipeline that will take it to production, it has passed through several very human eyes and hands again and again, forgetting or failing to pay attention that one of the main roles of a code is to serve as a means of communication between us and our colleagues can lead us to wrong choices when judging which process and tools to use, how to organize our work, what to evaluate when reviewing pull requests, among other things. After all, if the main purpose of a code is not well understood, how are we going to properly optimize its process of creation? You may not be putting much faith in my central argument that there is an intricate relationship between your code and the very human components of software development. You may think, like some authors like Robert, that claim that when you read the code, only the code really matters and nothing else. I have a much thorough response to Robert's claims themselves. This unfortunately is in Brazilian Portuguese, but I've heard that the Twitter translator does a very good job on what I've written, so you can just go over my Twitter and take a look. In short, translating this, I'm not a very big fan of this vision that the software, with capital letters, as being this clean, sanitized entity free of the problems that us humans have. In the case we're dealing today, I think that there is another observation that is more relevant. This observation is called the Conway's Law. It's not a law in the scientific sense of the term, but it is an observation that has proven to be valid over several tests since the 1960s. Conway's law says that software created by an organization tends to have a structure that mirrors the internal communication structure of that organization. That is, a company that has an extremely hierarchical structure divided into layers will have difficulties building an architecture based on microservices, by example, because that architecture demands a more free communication based on small autonomous groups. At this point, we start to notice how the form of communication between us, developers, with the rest of our company is actually ingrained in our software. If you want to reorganize your company's software structure, for example, migrating from a monolithic architecture to a microservice architecture, as it's in fashion right now, it is very likely that focusing only on the architecture of the code itself, without thinking about how people communicate in general within your company, this will cause a tension in your structure because you will be forcing your code into a path that does not have a mirror in how the information actually flows in that communication. So we can see that there is actually a very interesting relationship between how humans operate and the kind of code that they write. An important point in this discussion is the view that the code acts like this media for transmitting ideas. When considering this code, when considering the code in this way, we begin to observe certain patterns of usage. Whoever uses TDD or participates in coding dojos may be more familiar with that vision. Do you want to propose something new in a piece of code? How about writing a test which will fail, demonstrating the behavior that you expect? Perhaps this will provide a clearer view of what you intend than if you try to explain without having a code as a media. This is a strategy that I particularly use in open source projects. The discussion starts with a pull request that implements a failed test of whatever I'm thinking, and that test will work if the idea is implemented. From there, we can discuss many cool things. A point of debate when it comes about code are comments. There are many possible approaches here. One that is relatively famous is that our code should be obvious, so obvious that it needs no comment. I think this approach is interesting in theory, but not always feasible and may actually be a little bit counterproductive. Writing code full of gotchas and exotic uses of the language is bad and compromises readability. But at the times, we need to make use of some more complex structures. Trying to write those structures, obviously, makes as much sense as writing a PhD thesis using only the 100 most common words in the English language. You are going to end up with an extremely wordy text that fails to clearly represent what you want. One suggestion that I use and I give is that you take a look at your code and think if it's straightforward enough. Does its behavior depend on collateral effects or global states that are not obviously displayed in the code? Does it cause effects or change those states that will reverberate through the system? Those are good examples where a comment is very much welcome. In the same discussion on comments, there is another point of debate, which is documentation. Basically, a person who is going to use a function, class, etc., shouldn't need to read the code itself to use the ideas that are materialized in that code. Although the source code of these elements is the implementation of the idea itself, good documentation can help a lot in the collaborative effort. But what to document? There is this debate as well. Again, there's many different schools of thoughts, many different guides, etc. Consider this function in Python and its docstring. Well, it is definitely a very stuffy docstring, but put yourself in the place of a colleague who's using this Fibonacci function. That person doesn't need to know a lot of things that are happening in that docstring. The fact that the strategy is recursive, by example, is hardly an information important enough to be placed at the top. The question of an empty cache not being used, it's actually kind of obvious. Anyway, in this case, the strategy I like to use is to write what the main objective is in a sentence or two. So it's nice to describe the arguments and make some usage examples. It is also important to document whether the behavior that function has will vary according to global states or if it changes them. Implementation details about how that function does what it says it does are unnecessary in the documentation level. So a practice that I consider extremely important in any team are code reviews. They are the opportunity for a person to look at the code of each other and debate what's going on. After all, assuming that one of the intentions of the code is communicating ideas, only another human being can actually give us a parameter whether our code is fulfilling its role or not. Besides the obvious, more people looking at the code, more chance of bugs being spotted, and so on. In the previous topic, I talked about a lot about non-documenting the obvious, not putting comments on what the code already clearly says, but obvious and clear are very relative concepts, and they may not mean the same for everyone. Code reviews help your team align those. There is nothing better than another developer to judge if your documentation is in fact clear. Each team has its own dynamics, but personally, I think that it's very important that documentation deficiencies are reason enough for a pull request to be held pending further modifications. Besides that, code reviews are a moment that the team can use to pause and ponder if the way things are being executed and if the tools that are being used in the pipeline are actually serving the code's authors. Is that CI rule correct? Do we need to revise the rules of our linter? Are they fulfilling its roles as aids of the process or are they becoming a burden? A code review is a good time to deal with it. In another topic, APIs are common structures in modern architecture. I think that most of you have some contact with APIs in your daily lives. But when we think or discuss APIs, we often jump right into things like REST, HTTP verbs, JSON structures, and so on. But let's revisit the concept of API as an interface. The English term interface is usual and correct, but I sometimes think that we miss it when discussing APIs. Keep the interface part in mind, in the mind, help us see for what they really are. APIs are points of communication between two or more faces, between two or more different entities, each with its own functionalities. And again, we are in the middle of a communication problem. APIs, before they deal with code problems, they deal with implementation issues. Before all of that, they deal with communication between a side that offers certain resource and another side that uses that resource. Code that perfectly implements an API but does not offer any way for potential customers to discover its functionality and understand how to use them, it's not fulfilling its job properly. If you work for a company that has a backend team and a team of front-end developers working together, it is very easy to remember the interface aspect of an API, but it can also be very tempting to communicate what a certain endpoint does by informal means, such as Slack message, audio on WhatsApp, pasting around a post-it note with a specification, and so on. What about the next team members? What about next users of that API? Remember, the code as a means of communication ideas. Use that. I personally like to use automated tools to aid in the documentation and testing and so on. If you have never used anything from the Open API initiative, formerly Swagger and so on, take a look at those links. They are really interesting. Now, entering into slightly more abstract concepts, we have the notion of paradigms and fluency. A paradigm is a way of seeing the world, abstracting the world into our code. Each box in this photo is a different paradigm. For our topic today, the observation that I think is most important is to remember that a paradigm is not tied to a language and vice versa. If you program in Java, by example, declaring a single main class and writing your entire system in there, you are not doing object-oriented programming. Similarly, to know a little bit more about other paradigms besides our usual ones can help us see the problem from different angles and help us think of new solutions. I won't go into the detail over here because of time, but there was this very nice talk in EuroPython this year about the multi-paradigm solution to Sudoku. You are seeing the author first solution using pure object-oriented programming, and there is a pure functional architecture, and then we have this beautiful multi-paradigm solution that uses a functional approach where it makes sense when there is a pure data transform operation, and uses a more object-oriented process where it makes sense. It's a very interesting talk that happened in EuroPython. Take a look after. And programming languages, as well as natural languages, also suffer from the issue of fluency, with code with accent. When you learn a new language like Portuguese, you learn that table is mesa. So when you look at the table, you think, well, this is a mesa. You think, well, this is a table, and you mentally translate to mesa. This process works, of course, but it has two important limitations. It's slow because first you think in your native language and then your target language, and second, you are not going to use the expressions and words that are exclusive to the language that you are learning because they have no parallel in your native language. In programming, we write code with an accent. When we think of code first in our native programming language or the language you're most accustomed to, and we mentally translate the code into a target language. Um, those examples over here, it's someone checking if the elements of a list are all even. This is a C approach, a purely translated Python approach, and then you can see the evolution until we have a full fluent Pythonic approach in the last line. Fluency is something that we acquire over time, but it's important to know that this concept applies both to natural and programming languages. Unfortunately, I don't think there is a general recipe for acquiring fluency besides practicing. In Python, we have this great, marvelous book called Python, Fluent Python, by my friend and fellow Brazilian Pythonista Luciano Ramalho. In general, it's an amazing book if you never have the opportunity to read it. In general, try to ask yourself, what does this language have that's special? What does it have that I have never seen? Answering those questions might lead you to discovering hidden gems. And finally, we are back where we started, introspection. How to look to the entire zoo of tools we have available and look at them thinking about the ideas we discussed today. As you can imagine, there is no closed and unique answer. What you can do is follow some principles that I think help us make decisions. Well, having a lot of options is fantastic. We can do a lot of cool stuff. But in a team, consistency is key. Uh, Take a list of all the options that you have, discuss with your team, set a standard. Don't worry about getting everything right. You won't. Define some general idea of the workflow that you want. Which analyzer we will use, which is going to be the linkers and testers and so on, and collect feedback from your team about usage. Modify your standards if necessary. I quite like to use these tools alongside GitHubs and inside CI servers, even both. Pre-commit hooks are executed before a commit and are useful for keeping the repository free of non-compliant code. By example, I like to use the black auto formatter for my Python code. So I run black in my GitHub before I commit the code. Anyway, remember the humans. This is the most important point of our chat today. If you are going to put a CI server that will check if the code matches the style guide, why not add in the error message the contact of someone on the team who can help with that programming language. Something like, look, your code failed over here. Did you install the pre-commit hooks? The instructions are here in this doc. If you have problems, talk to Bidu at ingresse.com. Remember that the CI server, the linter, the hooks, they are not here to serve the code. They are here to serve the authors and readers of that code. And if they don't make those people's lives easier, they are not fulfilling their role properly. Do not accept that an assistive technology works only okay. We have a sea of resources available to us, and those softwares, they are actually working for us. In short, computing is increasingly entrenched with our society, and we have to deal with the complexities that arise from that. Computing introspects. Software makes software that makes software, and so on. Code serves mostly to communicate ideas between us. Tests and documentations and so on, they expand, they enhance the communicating powers of a piece of code. Code reviews are a very important time for the team to discuss their work and align expectations. Documentation and comment failures should be considered in the review and should be grounds for, hey, nice code, but please enhance your documentation over here. APIs are first and foremost interfaces. A hidden face is not very usable. Document them. Use of the introspection. Use the tools. Automate what you can. Leave the humans with the creative part. That's where we are good at. But don't be afraid to throw those tools away. Remember that they should serve us and not the other way around. Some reference from my talk today. The first is a very interesting talk by Anjana Vakel called The Language of Programming. She's a linguist that has become a software developer, and she draws all sorts of interesting comparisons between how natural languages work and how programming languages work. It's a very interesting talk. And the second one, John Osterhout, is an author from Stanford University, if I'm not mistaken, and he's dealing with, okay, we teach people that we need to make that we need to break our problems into smaller pieces and solve the smaller problems. But how do we actually go about that? How do we think about software design in a more abstract terms to try to figure out a general approach to software design? It's a very interesting talk as well, and he has a very interesting book based on that talk, and I highly recommend both of them. And thank you all very much. Those are my contact informations. Feel free to reach out, and I'm open to questions. I think we have time for some of them. So
Yes.
this is it.
Um, Thank you so much. Thank you for such a nice talk. I would ask everyone to send in their questions either in the chat or in the session Q&A. And I'll start off with the one that we have is that what are your thoughts on automatically generated code?
That's a really interesting question. Well, uh, a few years ago, they were really bad. All of them. Automatically generated code was, I don't know, it wasn't good. What I think is that if you're doing automatic generated code as a means of a transpiler, like taking one programming language and reaching to another programming language, that may make sense, but we are back into the fluency game. You don't actually have parallels between those that are efficient. So, for example, how do you look at a C code and you look at a for loop over there and you say, hey, this will be a nice list comprehension, or no, this isn't a list comprehension, this has to be a basic for loop. It's a very difficult problem. So I think that for transpiling code sometimes makes sense, but it's a fluency issue. And there are some people trying to build tools that go from a more human-friendly description of what the code is supposed to do to a full functional code. I have yet to see a tool that actually achieves that in a proficient manner. So I'm not a big fan of those.
Okay, perfect. Uh, I don't have any questions coming in at the moment, but I would say that if anyone still has any questions that they haven't been able to send in, feel free to reach out directly to Bidu, and I'm sure he would be happy to answer. You can just tweet to him. I've seen you're very active on Twitter. So,
Yes.
but with that, I just want to thank you for joining us at PyCon
Thank
Estonia.
you
Thank you
all.
so much for this talk and taking out time for us. It was a great talk, and I'm happy that we could actually make it work with our difference of time zones. For you, I would say
Yes.
have a great rest of the day. And for everyone else, in 5 minutes, we would jump on into the next session. So that's the last talk of the day. So please join us for that. And then we would have the closing. Thank you so much. Bye.
Okay. Thank you all. Bye bye.